Hi, welcome back to Manohar Academy. In the previous lesson, we have learned about overriding methods. So by overriding methods, we can change the behavior that we have inherited from the superclass. In this lesson, we are going to talk about dynamic polymorphism. For the dynamic polymorphism to work, actually we have to override methods. So that is the reason we covered override methods. And if you don't know how to override methods, what we mean by overriding methods, then please go to my playlist and watch the previous video. Okay. Now I am assuming that you know how to override methods. Also, I am assuming you have watched my previous video. Okay, now let's talk about dynamic polymorphism. In Java, the reference variables are polymorphic. Okay, previously the concept of polymorphic came, and at the time we said the methods are polymorphic, meaning there can be multiple methods or the method can take multiple forms, and all those methods need to have the same method name but different signatures. There we were talking about method overloading, not overriding, method overloading. And at the compile time, the method that is going to be called will be decided. So, but which method depends on the signature of the method, and we talked about static polymorphism there. But now we are talking about reference variable. For example, here we have defined a reference variable. The variable name is person1 and it is of type person. So this reference variable, as we know, it can refer to an object of its own type. That is perfectly valid. We have been doing that for very long. Not only that, the reference variable can also refer to an object of its subtype. For example, in the previous lesson, we created student and employee subclasses from person. So the reference variable of type person, it can refer to student as well as employee also. Not only person, it can refer to student, it can refer to employee. That is because the student is a person, because student class is extending the person class. A student is a person. Same is true for employee, because employee class is extending the person class. The employee is a person. So because of that, for a variable of type person, we can assign, or the reference variable can refer a object of type person, an object of type student, also an object of type employee. So all these statements are perfectly valid. Okay, now here you can see that for a person reference variable of type person, obviously I am assigning a student object. I am setting the first name for the person, that is Manohar. Then I am trying to call the toString method on this particular object. I am giving the reference variable. Now the variable person is of type person, but it is referring to a object of type student. So now which method is called? If you remember, in the person class we have a toString method which prints, hi, my name is Manohar. In the student class we have a method that says, hi, my name is Manohar, I am a student with admission number 0. So which one will be called? Will the toString method in the student class will be called, or the toString method in the person class called? We need to know that. But here the thing is, the method that will be called will be decided at runtime, because at runtime the actual object, I'm not talking about variable type, I'm talking about object type. Because the object is of type student, the toString method on the student will be called. So that is what we mean by dynamic binding. The method which is called will be decided at the runtime by the virtual machine, Java virtual machine, or the runtime environment. So here the important point is, we are overriding methods. We have one method in the superclass, we have overridden the same method in the subclass. If we did not override in the subclass, obviously we have inherited method from the superclass and that will be called. But whenever we override, then the method that is called is is the method that is available in the actual object type. Okay, so in this case, the method, this particular one will be the output. This is not the output, the second one is the output. We can see that in the IDE. Also, one more thing. Here, the reference variable is pointing to a subtype or subclass object. Now, the methods that we can invoke on this object or on this reference variable are limited to the methods that are available in the superclass. For example, here we know that in the person we have set first name method. In the student class we have set first name, which is inherited. Also we have set admission number. Here I can't call set admission number because this particular method is not available in the person class. So whenever a reference variable is pointing to a subtype object or any type of object, obviously it can point to only its own type or subtype, but the methods that can be invoked are limited to the methods that are available in the supertype class. So here set admission number, set employee number, these are all invalid. You can't call them. You can call only the methods that are available in the person class. So two things. The methods that can be invoked will be decided by the reference type, but whenever overridden methods are present, the actual method that will be called will be deciding on the object type. Let's see that in the IDE. Okay, first about polymorphic. Okay, now I'm going to create some objects, person 1. I'm going to assign whatever person object I have. For person 2, I'm going to assign student object. So this particular reference variable here, you can see it is pointing to the student object. So whether I write new student or use that, the person 3 reference variable is pointing to employee. Okay, now I'm going to print person 1. Person 2 and person 3. Let me comment them. Okay, now you can see, even though I am printing the persons, obviously they are all of type person, the method that is called is depending on actual type of the object. So here the person toString method is called. In the second case, the student toString method is called. In the third case, the employee toString method is called, because in first case we are referring to person object, in second case we are referring to student object, in the third case we are referring to employee object. But in all three cases, the reference type is of type person. So instead of this, what I can do is I can create array of persons, and let me assign a size of 3. Okay, and for the first object I am going to assign person. For the second object I am going to assign student. For the third object I am going to assign employee. And I am going to write for each loop I am going to print every person . Okay, now I am commenting out this part, or I am even removing all of these. I just created an array of persons and I have assigned person, student and employee. Let me use simple letter, even though I don't prefer that. Okay, let me run it now. So here you can see that we are just printing the person in a loop, whatever persons are there in the person array, and depending on the actual object I am getting all those things. So I can write a method. For example, I can include these three into a method, and the method name is, let's say, print person details. Oops. Okay, let's say I'm getting the persons, I'm not getting them, and let me move this here. Okay, here I have an array, I am populating the array, then I am calling a method and I am passing that particular array. So inside this array, if you see, it doesn't know which objects it's receiving. The array of persons, it may have only students, it may have only persons, it may have only employees. This is the generic code. So it doesn't have anything that says it is a student, it is an employee, or nothing like that. But to this I am just giving the persons array, and if you see the output, based on the actual type of the object, it prints either a person details or student details or even the employee details. So here the same code is, this is extendable. Now I can create the professor class, professor object. I can add the professor object to this particular array and I can pass that, and it will print the it will call the toString method on the professor. So that is all about the dynamic binding or dynamic polymorphism. So using dynamic binding, whatever method we are calling, that call is going to happen on the actual object type, not on the reference type. Here that is an example. Even though reference type is person, the method on either person or student or object, or employee will be called based on the actual object type. Okay, one more thing. Here let me create one more. I don't need to create any other, but let's say person 1, right? This is of type person, right? Even though it is referring to a student, it is of type person. Actual object type is student, the reference type is person. So here I can call the set first name, as I have shown. I can call that, but on this person reference variable, or here, even though the actual object is of type student, I can't call student set admission number. That is not allowed. As long as I am calling the methods on this particular reference variable, the only methods that are available in the person class are allowed. Okay, so that is about our second slide, right? That is what we have seen in the slide. When the reference variable is pointing to the subtype, the methods that can be invoked are limited to the methods that are available in the superclass. Okay, that is all about this lesson. We learned about dynamic polymorphism, how the overriding affects dynamic polymorphism, also the limitations on the methods that we can invoke when a supertype reference variable is pointing to the subtype object. Okay, last but not least, if you haven't subscribed already, please go ahead and subscribe so that you will get the alerts whenever I upload some new videos. Also, if you are benefited from this video, please make sure you like this video and also share it with your friends so that they can also watch, they can also learn. See you in the next lesson. Thank you.